Hello, this is Borotekin from EEL 3472C, and this is my oral presentation that I will cover Faraday cages. At the beginning of my presentation, first I would like to start by defining the Faraday cages so that we can understand what actually they are. Faraday cages are conductive surfaces that blocks the electromagnetic waves to pass inside of the material. Therefore, it can be said that a Faraday cage absorbs the electromagnetic wave and creates, or we can also say, induces current. In the figure 1, there is a metal wall, so it's a conductive material, and it can be seen from the second part of the image. When an electric field is applied to it, the metal wall absorbs the field and creates a voltage difference on the material, and this creates current on the material. In this situation, we can also say the metal wall acted as a Faraday cage. To be clear, I want to talk about how they work and why they are related to our class. So, the electromagnetic field creates a current on the material and it induces voltage, which creates current, and the current on the cage cancels the electromagnetic field to pass inside of the cage. There is the formula of the Faraday's law from our book. According to that, electromotive force is equals to minus derivative of the magnetic flux, which is also equals to minus derivative respective to time of the surface integral of the magnetic flux density, which is also equals to total EMF. In class, we covered time-varying fields and we studied on electromotive forces. We solved questions about motional EMF, which is also very similar case we covered in figure 1, slide 1. In class, we converted the current to magnetic flux density and we found electromotive force, and we divided the resistance to find the current induced on the cage, or we can also say the material. It is possible to give many examples on applications of Faraday cages. I selected three fields where Faraday cages are used. The first one is transportation. In figure 3, there is an airplane that I did as a project. It has many electronic devices inside of it, such as microcontroller or DC motors. If we consider it is made of a conductive and strong material, in a stormy day, even a lightning strikes to the plane, the electronic devices inside of the vehicle will not be damaged that much, because the plane acts as a Faraday cage. This also happens in the cars. The second one is security. In figure 4, for example, if the police confiscates a phone, they put it in a material made of a conductive element, such as aluminum, to block signals going from the phone or signals coming to the phone, and this provides the security. The last field is cooking. There's a microwave oven you can see in figure 1, in which our book has a long section talking about it. The machine creates electromagnetic radiation to warm the food. It is also made of a conductive material, but this time it prevents the waves going to outside of the machine. And these are the references where I took the figures from, and thank you for listening my presentation.